Good morning. This is problem number 3 from the 2016 test, and it is a free response non-calculator problem. I went ahead and wrote out what the graph looked like to start off the problem. Question number 1 talks about what happens at 10 as far as the graph of g of x is concerned. And we have defined that g of x is the antiderivative of 2 to x of f of t dt. Well, from that, we do know that g prime of x would equal to f of x dx. Again, that's just the fundamental theorem of calculus. One other thing here, you got a point for the problem if you had this written down in either A, B, C, or D. You just had to have that somewhere in the problem to get that point. Now, let's talk about f of 10, or g of 10. Okay, so g prime of 10, again, we're talking about a maximum or a minimum, so we're interested in the slope of g, and we equivalent that to f of 10, and f of 10 is 0, so that is a critical number. So let's see what's exactly happening here. Well, because f is negative from 8 to 10 and also negative from 10 to 12, that means that g is decreasing to both the left of 10 and to the right of 10. Therefore, we have neither a maximum nor a minimum at 10. All right, on to part B. Part B is talking about a point of inflection. What's happening here at 4? Well, I went a little bit different approach than what you might have seen on a computer explanation if you went ahead and looked at that. I also included that I knew that the second derivative of x was equal to f prime of x. So from that, f prime is undefined at 4. So because f prime is undefined at 4, that means that g double prime could be a point of inflection. Now, we increase g, I shouldn't say we, I need to be more specific. F is increasing from 2 to 4, and f is decreasing from 4 to 4, or 4 to 8, you could say either one. Therefore, we're changing from increasing to decreasing. Therefore, g goes from being concave up to concave down at 4, and we do have a point of inflection at 4. An explanation that I wrote down as I was working it, I said that since f goes from increasing to decreasing at 4, that means a point of inflection for g of x exists at 4. All right, on to part C. Part C, I took a different approach. Well, I worked out ahead of time. I didn't take a different approach. I just worked it out ahead of time. But I'm going to talk through part 1, and then we'll go on from there, and I'll just show you what my work said. We're talking about now the area. We're talking about values for g. So g has to do with the areas of f of t. Well, we're moving from right to left when we go from 2 to negative 4. So anything above the x-axis is going to have a negative value, and going from right to left, anything below the x-axis is going to have a positive value. So let's just talk through the first one, and then I'll put the work for the others up here. This is a triangle, base of 4, height of 4. So it has an area of 1/2 base times height, so it would be half of 16, which would be 8. So we have an area of 8 here, but that means that g of negative 2 would be negative 8. All right, well, this area here would be positive 4, and since we are going right to left and we are below the x-axis, then the area from negative 4 to negative 2 would be positive 4. So we have negative 8 plus 4, which would be negative 4. So g of negative 4 is negative 4. Now, I did it for the rest of them. You can look along on your graph as I'm talking through this. G of negative 2, we talked about that earlier. That was going to be negative 8. All right, g of 2, I said from 2 to 2, and that's 0. G of 4 is 4, because from 2 to 4 we have 4. G of 6, again, you've got that full triangle in there, so it's 8. 4 plus 4 is 8. All right, now, I skipped 8 and just went straight to 10 because I knew I had equal triangles both above the x-axis and below the x-axis. I knew it was going to be 8 minus 8, which was 0. And then from 2 to 12, we're below the x-axis, so we get negative 4. Therefore, we have an absolute minimum value, which is negative 8. Now, it exists at negative 2, but the value is negative 8. You need to make sure that you had that correct. And the absolute maximum is 8. Now, the absolute maximum exists at 6, but the value is actually 8. Now on to part D. This part was worth 3 points. On to part D. And this asks just where on the graph is G decreasing. And G would be decreasing I think I have that right. From, or did it say where G is negative? Give me a second. Let me look at that problem again. I'm sorry, it just asked where G was negative. So G is negative from negative 4 to 2. Now it's important on this that you would have included negative 4. Now, for some reason, well, did it say less than or equal to, or just less than? It said less than or equal to. Okay. So it would be from negative 4 to 2. And then here at 10 again, we pick up with being negative. So it would also be from 10 to 12. And that is the solution to question 16, or question 3, 2016. Have a good one.